When you study chemistry, there's a lot of things that come up when you're making measurements, and we'll refer to it being an intensive or an extensive property or variable. And what we mean by these is we really mean it's a property that changes with amount, or it's a property that's more intensive, which doesn't change with amount. And right there is really what your definitions are. Any property that you can measure that as you change the amount of substance, but that property doesn't change with the amount, is called intensive. A really great example of this is temperature. It's one of our premier intensive variables, if you will. Great example, if you had a glass of water that's 25 degrees C and you pour half the water into another glass and ask yourself, now what's the temperature? The temperature is still 25 degrees because it's an intensive property. It absolutely does not matter about the amount that you have. It's intensive. Now, let's compare that to the mass of the water. If I have a glass of water, I know its mass is, say, 500 grams, and I pour half of it out. Now the mass is not 500 grams, it's 250 grams. That's because that's an extensive variable. Extensive properties vary with the amount, and we love to quantify amounts. We quantify in mass in grams, we quantify amount itself in moles of substance. We quantify length. How long is something? How tall is something? Volume's a great example of an extensive property that actually brings in length 3 times, height, depth, and width. You multiply all 3 of them, you get yourself a volume, which is very extensive. You get more amount, you get a bigger volume. An interesting thing, though, about extensive properties, if you ratio one extensive property against another extensive property, you get an intensive property. A great example of this is density. Density is mass per unit volume. The mass is extensive. The more you have, the more mass you have. Volume is extensive. The more volume you have, the more the number goes up. If you ratio them, mass divided by volume, you get density, and that's intensive. The water example I gave earlier, when I pour it, it doesn't matter when I split it. The density is still approximately 1 gram per milliliter. Even in the part I poured off, it's 1 gram per milliliter. So this is an important concept you will see over and over when you're answering problems numerically in a chemistry class. Is the answer an intensive or is it an extensive property? One last thing. Extensive properties by themselves tend not to reveal much about what the substance actually is. For example, let's say I have a substance and I tell you it's 500 grams. That really tells you nothing about the substance other than the amount I have. But if I tell you I have a substance that has a density of 1 gram per milliliter, it really limits you on your choices of what that could be. And so what we tend to do in the sciences and what we do in chemistry is we list intensive properties. And if you get a good listing of them, it truly identifies that substance as being a unique version of those intensive properties. Meaning, we like to characterize matter by listing intensive properties. And that's really what the importance of both of these things are, and you need to keep track of them.